Hi everybody, this is my Law, Sines and Cosines Lab 1 for pre-calculus, and I'm going to do some of the word problems because I think what makes these tricky are trying to draw the picture. So this one is from a point 50 feet from the foot of a vertical monument. So that's pretty cool. So I'm going to draw a vertical monument. So vertical means straight up and down. And there's my vertical monument. This says 50 feet from the vertical monument. To measure the angle of elevation to the top of the monument is 65 degrees. So I'm going to come over here. And basically what this is telling you is this is my monument here. So I'll just put M for monument. It's this tall thing here. And they said it's 50 feet from the foot of the monument. So this is the base. So here's 50 feet. And then they said the measure of the angle of elevation of the top. Well, what they're saying is if I were standing here and looking up, this would be 65 degrees to the top of the monument. And then they said, what is the height of the monument? So I don't know. Put an X. I have no idea. This one can be done a couple different ways. One of the ways I want you to recognize is this is a right triangle. So there's a couple things going on. I could do law sines because I'm looking for something opposite and I have this. And if I know this is 90 and this is 65, I know this angle up here is 25 degrees. So I do have an angle opposite. So I could say, oh, 50 is to the sine of 25 degrees, as my monument X is to the sine of 65 degrees. Okay, that's cool. So I can go through, do this cross multiply. So I have X times the sine of 25 degrees equals 50 times the sine of 65 degrees. And divide by that, I have X is 50 times the sine of 65 degrees all over the sine of 25 degrees. And you just put it in your calculator just like that. And they said to the nearest foot it comes out to be 107.225 feet. So my answer is going to be X is 107 feet tall. So that's how tall my monument is. All right. If you did it that way and you understand, you feel good about it, life is good. But I want to show you the alternate way that we did earlier on. And if this is a right triangle, I can label this hua. So this is my hypotenuse. This is my opposite of my angle, and this is my adjacent. I'm looking for the X on my O, and I have something by my A. So I'm going to do the tangent of 65 degrees is opposite, which is X, over adjacent over 50, which we did a ton of these earlier. So that's a 50. So if I cross multiply, X is 50 times the tangent is 65 degrees. And guess what you get, guys? Lo and behold, the same darn thing, 107.225 feet, but they want us to round it to 107 feet. So you could do it either way. They both work. And the reason why this one worked is because it's of this right angle. It's a right triangle, so I can use SOHCAHTOA. Well, that was fun. And my computer's not going crazy, so let's see if we can try another one. Here's 25. I have a vertical telephone pole. Oh, another vertical one. So let's draw it. Vertical telephone pole. Okay. That is 15 feet high. Okay. Is being braced by two wires from the top of the pole to 2 points on the ground that are 5 feet apart on the same side. That's important. So it's being braced here. So this is the ground. And then it's being braced here. So I have two wires at the top of my pole bracing it. And they said, okay, that they're 5 feet apart. So I'm going to put 5 feet because these two poles are 5 feet apart on the ground. Okay. Now, this is assumed to be a right triangle. I want you to recognize again that you have a great big triangle, a big right triangle, a small right triangle, and you have this little skinny triangle here as well. And they basically want you to find, first of all, they said the shorter wire makes an angle of 65 degrees. So this is 65 degrees with the ground. And it says find the length of each wire. So I'm going to label this wire as X and this wire as Y, just because, all right? So I look at this, I'm like, oh, cool. I know in this one right here, this is a right triangle. If this is 90 and this is 65, I know this is 25 degrees. So I'm just kind of labeling everything I know. I know if this is 65, I know the rest of this way, it's a linear pair, is 115 degrees in this little skinny one. Okay? And I look at this and say, all right, I want to find X and Y. I could probably find X pretty good. How would I do that? Well, if I know, okay, if I'm trying to find all the sides of this, if this is 5, I could actually, because I'm doing the Pythagorean theorem, if I could find all this side, I could do that. There's a lot of things I can do. But I'm looking at this and like, well, I don't really know what this piece is, so I can't do the Pythagorean theorem of the big one. So I look at it and say, you know what I'm going to do? I want to see if I can find out what y is. So watch what we have here, okay? I have this whole thing here. So I can say, of this one triangle here, x is to the sine of 90, okay, as 15 is to the sine of 65. So I can do x is to the sine of 90 degrees, because this is opposite, is the same as, okay, so I got x is the sine of 90, because this is 90 degrees, as 15 is to the sine of 65, okay? You also, in that one, could have done SOHCAHTOA. That works too, because you could have done the sine of 65 is opposite over hypotenuse and done that. But I just did a law of sines, because as I do this, I see the sine of 90 is 1. So if I cross multiply, you have x is going to equal 15 times the sine of 90 degrees, which we know the sine of 90 degrees is 1. So it's really 15 divided by the sine of 65 degrees. And I just skipped a step. And when I did, I get x to come out to be 16.6 feet, because here they wanted us to go to the nearest tenth. So this is 16.6 feet right here. Okay, so I'm good with that. Now what I'm going to do is I'm going to look at this little triangle here. And I could say, oh, this is 115. This is side angle side. I can find y by doing y squared is the other two sides squared, 16.6 squared plus 5 squared, okay, minus 2, this is squared, minus 2 times 16.6 times 5 cosine of 115 degrees. That's one way to do it. Or you could done the big triangle. It doesn't matter. When I do this, I get y squared to be 371.41. And if I take the square root on here, I get y comes out to be 19.3 feet. Okay, so you take the square root of both sides. So this comes to be 19.3 feet. All right, so we found both. And remember, there's various ways. On this first part, we could have done SOHCAHTOA on this. And this part, we could have used the bigger triangle to do that. It doesn't matter. You could have used the whole big triangle to find the law of cosines. So there is 24 and 25. I hope it helps.